Well, good morning, Honors Algebra 2. It is Monday, April 6th, and it's good to see you again. Today, before we start our lesson today, tomorrow you're going to have your test on Chapter 12. Now, this is actually Sunday when I'm recording this. I am going to get your quizzes graded. I've already sent the answers to your parents. I can't send them out to everybody because Alex is not back with the class yet since he traveled back to China. So, but ask your parents for the answer key and you can look over your answers. Now, tomorrow for our Zoom meeting, we can do take questions before you take the test on Tuesday. I'm happy to do that. And then we can have a Zoom meeting on Tuesday to go over the homework, or we can go over homework on Monday. So y'all just let me know via the class wall what you'd like to do during the Zoom meeting on Monday. We can review for the test, or we can work on today's homework. Now this is a more challenging lesson, I will tell you that. And so I'm expecting more people to tune in. Notice on the class wall that our Zoom meeting still has the same ID, but we now have a password to get in. And you'll be asked for the password, and I made it really simple. So look on the class wall to see that. Now let's go ahead and talk about 13.1 Part 2, the sequel. Okay, we learned last week that radian measure can be converted with degree measurement, and that 360 degrees is 2 pi radians, and then 180 degrees is pi radians. Now, the other thing I want you to remember to be successful this lesson is the area of a circle. Area of a circle is pi r squared, and the circumference is 2 pi r. We used to call it pi d in 7th grade, but this year, and most of the time in geometry, you will see it as 2 pi r. It means the same thing, 2r equals d. Now, we're going to first learn about how to find the arc length of, well, the length of an arc, the length of an arc. So here, S is defined to be the length of this arc, okay? And this arc is intersected by this central angle, has the vertex at the center, this central angle of 60 degrees. Now, we're in degrees right now. Let's do that first, and then we'll go to radians. So I want to find the length of this arc. Well, think about it. It's just a fraction of the circumference. And so to find the length of S, or the value of S, I'm going to take my degrees, whatever they are, of my central angle, divide it by the number of degrees in an entire circle, and multiply it by the circumference. So we have a fraction of the entire circumference is going to be the length of this arc. So let's use this example. This central angle is 60 degrees, and it intersects this arc here, from here to here, to give us the length. So I have 60 over 360 times 2 pi r. Well, what is r? R, I made 1 centimeter, made it easy. So 60 over 360 reduces to 1/6, and we have a radius of 1, so 1/6 of 2 pi, and that reduces to pi over 3 centimeters. So the length of this arc is pi over 3 centimeters. If the directions tell you to change it to 3 sig figs, you would go ahead and take pi and divide it by 3 and give me that answer. I just left it in pi for this example. Now, let's go over and talk about arc length using radian measurement instead of degrees. So the principle is still the same. The length of this arc is going to be the measurement of this angle divided by the total measurement in radians. Now, theta is always used for radians. I used x for degrees to differentiate. So to find the fraction that this arc is of the whole circle, it's going to be the fraction of the circumference. But with radians, instead of this in degrees, it's in radians. And so I'm going to take my radian measure and divide it by the total radian measure in a complete circle, which is 2 pi radians. And so if I take my value of a particular angle in radians and divide it by the number of radians in the complete circle and multiply it by the circumference, the beauty here is 2 pi is going to cancel out. So look at that. 2 pi is going to cancel out, and the measurement of my arc is simply the radius times the number of radians. Okay, so my formula is my arc length is r theta, r theta. Here is my formula if I have degrees, and there will be some degrees on the homework set, and here it is if it's in radians. So let's go ahead and find the length of this arc with using this new formula. Well, the radius is 1 centimeter again, and this is the measurement of my angle in radians. This one has a measurement of 2 radians, and so it is simply 2 centimeters. Done. R theta, where theta is the number of radians in your central angle. Okay, now let's go to the area of a sector. Well, the area of a sector, let's start with degrees. Same thing, it's going to be a fraction of the central angle over 360 times the complete area, because a sector is just a partial area, okay? So it's how many degrees over 360 times pi r squared. Now, I'm going to go ahead and look at the, change it to a formula for radians. So instead of degrees, I'm going to go to radians, divided by the total number of radians in a complete circle, 2 pi radians, and multiply that fraction by pi r squared. This is the fraction of the sec that the sector takes up in the whole circle times the area of the complete circle. Now look what cancels out here. Pi cancels out, and so I end up with, now the formula of the book will say 1/2 and then r squared theta. It will use that in that order. Okay, now what I can also do is this. I know that theta, let's look over here. Theta, if I isolate theta, theta is my arc length divided by my radius. Well, if theta is my arc length divided by my radius, I can just, for theta, plug in arc length divided by radius. And then I have a second formula for the area of a sector. And that is the r squared over r is going to cancel out. And I'll have 1/2 the radius length times the arc length. Now this one you would use, obviously, if they give you the arc length. This one you would use if they gave you the measure of the central angle in radians. And I'm going to go ahead and box this too if you come across a word problem that has to do with degrees instead of radians. This is my degree formula for area of a sector. Both of these are used for the area of a sector when you have radians. Now, let's look at this example over here. I have a circle, and it has, that's kind of hard to read, sorry guys, it's 1.5 radians is the measure of this angle, 1.5 radians. And it has a radius of 3 centimeters. I'm sorry, somebody's texting me. All right, let me turn that down right now. Okay, now let's go ahead. What are we given? We're given the radius, and we're given the measurement of the central angle in radians. And so I'm obviously going to use this formula because I do not have the arc length. I do not have the arc length to find the area of the sector. I only have the radians. So I'm going to use 1/2 r squared, 3 squared, times the measurement in radians, 1.5, and I just crunch that out. This is the area of this sector in centimeters squared. Okay. So those are my formulas. I boxed for you 1, 2, 3, 4, 5. Now let's move on, and we're going to talk about 2 different types of speed or velocity. Okay. Now the first one I'm going to talk about is linear speed, and I'm going to compare that to angular speed. Now you know that distance equals rate times time. Rate is your speed. So we're talking about speed, velocity, rate, all of those things are synonymous. Now, we know that in our plain old distance equals rate times time, rate of speed is equal to the distance traveled divided by the time. So now we're in a chapter on circles. So what we're going to do is talk about the speed of a particle or just anything that is traveling along the outer rim or the circumference of the circle. So I'm talking about what is the speed traveled around the circle. Okay, now we go ahead and call it V for velocity when we're talking about circles, but it's the same thing as rate. It's going to be the distance traveled divided by the time, which is what we just saw here. But distance now, since we're traveling around the circle, the distance is actually going to be s, the measurement, the length of the arc. Okay, so velocity, linear speed around a circle is going to be the s length traveled around the edge of the circle divided by the time. We'll come to an example on that in just a minute. Angular speed, new thing. Angular speed uses the Greek symbol, I forget what the name of it is, but it looks like a W. Okay, now instead of it being distance, say in centimeters or feet or inches, your angular speed is how many angles do you go through, how many angles do you go through in a certain amount of time. What's the measurement of an angle that you go through at a certain amount of time? So it is going to be in radians, okay? So as you go around the edge of the circle, how many radians are there as you go a certain time? How many radians do you pass through as you go around the circle? Okay, so what is the measurement in radians? What is the angle measurement in radians over time instead of a length over time? Your angles per time as opposed to your length per time. Okie dokie. Now, let's remember this. On a circle, one complete revolution in length, for like a circumference, one complete revolution is 2 pi r. This is the diameter. This is your length that is traveled as you go all the way around the circumference of a circle. We all know that. In radians, one revolution is 2 pi radians. So you'll have 2 pi radians as you go around the circle. Okay, this is an angle measurement. This is a length. Okay, now, a Ferris wheel is 60 feet in diameter, and it makes 1 revolution per 3 minutes. We're going to find the speed of the seat. If you're sitting in the seat and you're going around the Ferris wheel, we want to find the speed of the seat on the rim, asking for the linear speed that you're traveling, and then the angular speed, okay? How many radians are you going through in a certain amount of time? Now, this is the way I worked it out. This is a problem in the book, and I like to use unit multipliers, okay? So I think it's the easiest way to do it. So let's look here first. I'm trying to find the speed, the linear speed, which is going to be the distance I travel, s, the arc length I'm traveling, divided by the time. Now, to begin with, the speed they give me is 1 revolution in 3 minutes. So I'm going to write that speed, 1 revolution per 3 minutes. Okay, I'm writing it right here, 1 revolution per 3 minutes. And all I have to do now is change 1 revolution to a length, okay? And this length, we're trying to find the speed, the velocity is the actual length, not the angle. And so we're going to multiply. Well, we have 1 revolution per 3 minutes. We're going to now, remember unit multipliers, if we want to convert a revolution to a distance in feet, revolutions has to go down below to cancel out, and 1 revolution is 2 pi r feet. Well, instead of 2 pi r, this is really pi times the diameter, okay? Pi d and 2 pi are the same thing. So I'm going to go ahead and say that the 1 revolution is a distance of pi times 60, okay? Pi times 60 or 60 pi. I probably should have written 60 pi. But so this is the length around the circumference, and what happens is my revolutions are going to cancel out. Now, what do I have here? I've gone from revolutions per minute to feet per minute by calculating how many feet are in 1 complete revolution. So I'm going to cancel 60 over 3 is 20, and I have a pi there. And so 20 pi to 3 sig figs is 62.8 feet, and I don't have that right because this is a velocity. What is this? Feet per what? Minute. I'm glad I caught that. Okay. Now, let's find the angular speed. So instead of what is our distance in feet per minute, we're going to figure out the radians we travel per minute. Now I'm going to go back to my initial speed. I'm going to start the exact same way, 1 revolution per 3 minutes. But this time I'm going to convert my revolution to radians. And every single time 1 revolution is 2 pi radians. We know that. So I'm going to cancel out my revolutions here, and I end up with 2 pi over 3 radians per minute. Now 2 pi over 3, follow the directions on the homework. It may tell you to round it to 3 sig figs. In this case, it's 2.10 radians per minute. Whereas, and that's your angular speed, this is your plain linear speed, okay? So we use unit multipliers, and remember that one revolution is 2 pi radians, and in angle measurement, and 1 revolution is 2 pi r with a length in whatever units you're in, 2 pi r units in when we're talking about linear speed versus angular speed. And I know that's a little tricky. You can certainly meet me for the Zoom meeting to get some help on homework problems. And like I said, I'm happy to meet with you Monday and or Tuesday. So just let me know on the class wall what I can do. I'll be there in my meeting at 10 o'clock on Monday, and you can just join with a password, and we'll help you with whatever you need. Well, I hope you have a great day, and I sure do miss you, and hope we're going to be able to see each other before school's out, praying for that. So we'll talk to you either later today for the Zoom meeting or Tuesday morning. Have a great day.